Good morning students. In the continuation of electricity, today we will discuss the exercise problems given. The typical problem which is important in the board point of view, we are going to discuss that. Already we have done few examples and in-text questions also in the previous classes. In a continuation of that, today we will go with the exercise 1. In your textbook, refer page number 221, question number 6. Actually, it says that a wire with a diameter of 0.5 millimeter is given and the resistivity of that particular wire is 1.6 into 10 to the power minus 8 ohm meter and it having the resistance of 10 ohm. Now, you are expected to find out what is the length of the given wire and if the diameter is doubled, what will happen to the resistance of the wire and what is the relationship between the old resistance and the new changed resistance. All these three are in a same question they have asked. So, first we have to list out what are all the data given. So, it is given with a diameter, it is 0.5 millimeter, then we have, you know that you have to convert into meter. Like, then we know the relation, radius is equal to diameter by 2. So, 0.5 by 2 is nothing but 0.25 into 10 to the power minus 3 meter we have found out. Now, specific resistance, that is resistivity of the material given as 1.6 into 10 power minus 8 ohm meter, resistance also 10 ohms given. Now, we have to find out what is the length. We know the formula R is equal to rho into L by A. In rearranging this, we find out the formula for L. L is equal to R into A by rho. What is A? A can be calculated using the formula of pi R squared. Now, in the formula of L, you substitute the known values. That is your R, your area pi R squared, this is your pi, this is your R squared by your rho. So, you have substituted all this value and you compute to do this. See, when you are doing this type of squaring, it has to be 0.25 into 0.25 into 10 to the power minus 6. You should not say that 3 squared, so it is 9. No, when it is in the exponential power, then it both has to multiply each other. So, 10 power minus 2 the 10 power minus 3 the whole squared is equal to 10 power minus 6. When you simplify this, you will get 1.22 into 10 to the power 2. It is a positive 2, so you include those 10 power 2 inside. So, you are having the length is equal to 1.22.6 meter. You can round off to only single decimal, no need to go for the second decimal. So, it is 1.22.6 meter. Now, we know the length. Now, the next part of the question says what will happen if the diameter is doubled. That is, what is the old D given 0.5 in. Now, what is the doubled means 0.5 into 2 millimeter. This is what the new doubled D. Then what will happen to your R new? D by 2, 2 get cancelled. So, your R new will be 0.5 into 10 to the power minus 3 meters. Now, you are going to find out what is using this R new. You are going to find out what is the R dash. You know what is the specific resistance. Whenever we already learned that in the specific resistance, the resistance alone changes with the change in the length and area, whereas specific resistance or resistivity of the material will be the constant value. That is we have already learned in that, right. So, the specific resistance is the same value and the length what we have found out already 122.6 meter. I have substituted area pi into R squared. Only my R I am going to place this new R. So, when I substitute and simplify, I got my R dash is 2.5 ohm. Now, the third part of the question says that what is the changes in the R you have to find out. So, I have taken a ratio of R dash by R, that is new resistance by the old resistance. What is the new resistance? 2.5. My old resistance is 10, that is 1 by 4. So, R dash is equal to 1/4 of the original resistance. You may raise a question, why you have to go for R dash? Why don't you go by R dash? Yeah, you can go by R dash. What is R dash? 10. What is R dash? 2.5. It is nothing but 4. Again, you will get the ratio of R dash is equal to 4. You can write R is equal to 4 times of R dash. R dash is equal to same 1 by 4 times of R. Whatever the method you do, you will get the formula, final answer is the same, that is new resistance is 1 by 4th of the old resistance. See students, with a single question you are expected to do so many questions, so many subdivisions in that. So you should be very quick in your computing value. This all can be asked in a 3 mark. Every subdivision will carry a 1 mark. Instead of they are asking you to find out, here they said that it is R is doubled, sometimes they say R is decreased, or L they have given and L is doubled, what will happen? So according to the question asked, try to change the formula what you are using. So it is easy for you to solve it. And the next question is question number 7. See, this question number 7 can be directly asked as a question, and sometime it may ask us, given as a graph and ask us to interpret the data, right. So, look into the question, they have tabulated the value of I and V, that is in a Ohm's law experiment for our respective current, what is the potential difference across this resistor. They have started to denote 5 values, that is from 0.5, 1, 2, 3, 4 amperes, what is the potential drop across each thing they have found out and tabulated. And they ask us to find out what is the value of resistance. We know that the resistance, we know that by Ohm's law, V is directly proportional to I. We are writing V is equal to IR, introducing the constant of R. So, what is the final conclusion we may come? V by I is equal to R. R will be the constant, right? We know this by Ohm's law. Now, to solve this problem, I can employ 2 methods. We know what is Ohm's law graph, right? V by I is a constant, it gives a straight line. So, the same problem you can work out using, take a graph paper from your graph note or take your graph note and do that. Plot the value in x axis take y and in your y axis take I. Actually, in your textbook it is given in the vice versa. In y axis they have given V and x axis they have given I. Both are accepted, but when we go for the higher level, that is in the senior secondary level, or when you go for the further level of your education, in your higher education, where we will generally take V in our x axis and I in our y axis. So, to make you to follow that habit only, I have given this type of graph. So, now plot the values. Even if you change and then what is given here, you can plot V and here you can plot I also, nothing going to change. You will get the same value. So, I have taken and I have roughly plotted here. When I plot this graph, I will get a straight line. So, from that straight line, I am going to find out the slope of this straight line. So, what is my slope of the straight line is nothing but V by I R. So, I have joined this part, that is AC denotes my V value and my BC denotes what is the I value. So, you can extend this part and you can find what is your I value, and likewise from here to here you can find what is your V value. Now, R is equal to V by I is nothing but AC by BC. When you plot in an exact and you found out, it should be nearly equal to 3.4 ohm if you are exactly plotting. So, we have already started to complete the one method graph. If you found that no graph is somewhat difficult for you, you can go with the alternate method, that is by using formula R is equal to V by I. See here how many R's you can find out. By doing this one you can find out R1, by doing this you will find R2, R3, R4 and R5. So, what is the total mean? R mean is equal to R1 plus R2 plus R3 plus R4 plus R5 divided by 5. When you do individually find out the R and you finally add everything, sum up everything and find the average of that, you will get what is your R mean. This both R mean are approximately equal to 3.4 ohms. So, why I have discussed the 2 methods also. When you are doing in the notebook, do see separately what is your R1. See, for R2 by looking easily you can say it is 3.4 by 1, so it is 3.4. This is 6.7 by 2, that is 3.3 something. So, easily you can say everything will be related to this value 3.4. Why we have discussed 2 method also, sometime if such a type of graph is given in your question paper and you are expected to compute what is the R value, instead of that no need to go for this much of big calculation. Comparingly, this calculation is somewhat tedious than this, because here directly there is only one division, only one time you are going to calculate your R, this R will be definitely mean of this R. So, it is easier method when compared to this formula method. Anyhow, you have to practice both the methods, and if the data is given like this, either by graphical method or by formula method, we can easily compute the value of what is the resistance. So, work out this problem in both the methods also in detail, take your graph and plot it and you find the value. So, you will get approximately 3.4. Sometimes if we change the scale value, it may be 3.39 or 3.41. There is a small changes also can be accepted. Okay. Now, let us move on to the important next type of a sum. It is question number 10. How many 176 ohm resistors are connected in parallel which are required to carry 5 ampere of current on a 220 volt line supply? That is the question. So, here we are asked to find out what is the number of resistors to be placed in our circuit, where we have the current flow as 5 ohm and their voltage is 220 volts. We know what is the number of resistors given. So, you take that as a x number of resistors. So, you have taken total number of resistors be x. By Ohm's law, we know that V is equal to IR, R is equal to V by I, and we know what is the resistance of the circuit is nothing but 44 ohms. By the question itself, they said that how many resistors are connected in parallel. So, what is the resistor I am getting here? Resistance here is nothing but the effective resistance when I connect all resistors in parallel. So, 1 by 44 ohm is equal to 1 by 76 plus 1 by 76, because each resistor is 176 ohms, that is also given in that. So, up to x number of resistors I have connected in parallel. So, I can sum up this factor as x by 176. So, 1 by 44 is equal to x by 176. So, by cross multiplying simplification, we are find out answer finally with the 4 resistor. X is equal to 176 by 44. So, totally 4 number of resistors are connected in parallel, that is R1, R2, R3, R4. So, each are having 176 ohm. 4 resistors are connected in parallel like this in a circuit with which is having the net effective resistance as 44 ohms, and it will carry 5 ampere of current for a supply voltage of 220. Like this type of a question can be asked. Instead of that, they may change the number. So, this is also one of a important type of a problem in this lesson. Okay, now let us move on to the problem of how to calculate energy and power. So, now you refer in textbook page number 220. It is given that in an electric motor, it is carrying 5 ampere of current and a supply voltage of 220 volts. And what is the power consumed by that when it is using 2 hours? This is what your questions. So, and what is the amount of electrical energy used here also asked. So, E we do not know, P we do not know. Instead, first we will go with what is the power. Power is equal to V into I. We know what is V, what is I. When you go for a product of this, you will get 1100. This can be written as 1.1 kilowatt hour. Okay, generally we said that in commercially we do not use watt simply, we have to use kilowatt hour. So, I am using here, I have changed this power into 1.1 into kilowatt, 1.1 kilowatt hour. What is the formula to calculate energy? Energy can be power into time taken. Already my power is in hour, and what is the time given here? This is also in hours. So, no need to convert this in terms of minutes or seconds. So, directly you multiply 1.1 into 2, it is nothing but my energy is 2.2 kilowatt hour. This much of amount of energy is taken by the electric motor when it is operated for 2 hours. Children, with this we are winding up this chapter electricity. In this lesson, we have worked out all the maximum number of in-text questions and examples and exercise sums also. Whatever is left out, it is based on the same type of questions. Try to work out these problems in your notebook. Read the lesson thoroughly 2 or 3 times, then it is very easy for you to understand all the concept and the derivation of combination of resistors, Joule's law of heating effect and Ohm's law. Keep an eye on that, repeatedly learn. Write, learn and write, practice this method, and you can be very well about this lesson. You will be very clear and you can score better in your upcoming test also. Thank you children, stay home, stay safe.